I don't fear conservative Protestants anymore. And as someone on the right that's been targeted for cancellation, I do tell them, I'm like, you might think I'm going to hell, but we got the same enemies at this point. So you guys need to chill out.
The Rational View is a weekly series hosted by me, Dr. Alan Scott, providing a rational, evidence-based perspective on important societal issues.
Hello, and welcome to another episode of The Rational View. I'm your host, Dr. Al Scott. In this episode, I'm continuing my series on evolution and creationism, and I'd like to dig a little deeper into the evidence supporting evolution and universal common descent. In my opinion, the strongest evidence in favor of evolution right now is the emerging and exploding scientific field of genetics and resulting from the advances in genome sequencing. Today's interview is from someone whose writing I stumbled across on Cicero.ly, and I'm hoping to get a broad overview of the impact of modern genetics on the debate regarding evolution and creationism from someone who's been following the field closely. As always, if you like what you're hearing, I'd love to see you press like on your podcast app, share the episode with your friends, post about it on your social media feed. I'd love to do that. Come visit my website at www.TheRationalView.ca. Razib Khan is a geneticist. He's written for the New York Times, India Today, and Quillette, and runs 2 weblogs, Expression and Brown Pundits. His newsletter is Razib Khan's Unsupervised Learning. Razib, welcome to The Rational View.
Hey, what's up, Al?
I'm doing well. How are you?
Yeah, I'm okay. It's it's not a cold winter really here in Austin, but we got a cold couple of days. So, in terms of weather, it's okay.
It's minus 32 this morning here. It hurts to breathe.
It's probably 32 here. So, that's really low in Austin.
Okay. So before we get started, I'd like to address an issue that I'm sure you're aware of. I discovered your Wikipedia page, and on it, Michael Schulson is referenced there as saying, your career is an example of the murky line between mainstream science and scientific racism. Now, this is a troubling statement. Why would he say that?
I've written for publications that have gone in different directions over the years, over the last 20 years. So, that's the primary reason. Mostly it's because the New York Times hired me in 2015. And if you want me to be totally candid, someone like me should not be working for the New York Times. So, of course, they unloaded everything that they could. So that's that.
So I brought you on to discuss genetic science and the evidence for evolution. I've been exploring evolution and in light of the evolution and creationism so-called controversy. But the field of genetics has exploded recently after the Human Genome Project. What excites you most in this field right now?
We basically know the whole history. Well, we can know the whole history of the human past if we want to, because of ancient DNA, at least in terms of the demographic and cultural, let's say biocultural complexities, because we don't know the languages that people are speaking 30,000 years ago. But to give your listeners, your viewers, a concrete example, we know exactly the demographic turnover in Pleistocene Europe to maybe 90% precision now, in terms of there was the initial modern human incursion 40,000 years ago. They left no descendants in Europe.
Wow.
They're as genetically related to East Asians as modern Europeans. They left no descendants. The second wave associated with the Gravettian culture, which if your listeners have read maybe a little earlier than Clan of the Cave Bear, but the Gravettian culture is the classic mammoth hunters.
Okay.
So a lot of the things in Clan of the Cave Bear of the modern humans are actually more Gravettian than their Autognatian, which is the culture that really interacted with the Neanderthals. But in any case, this culture left only a minor imprint genetically. And then the Magdalenians, depicted in a movie about a boy and his kind of pet wolf, that's 18,000 years ago. They left a minor impact. And so most of the hunter-gatherer ancestry in Europe, for example, dates to after the last glacial maximum, 15,000 years ago. So, that's a fact. Most of the ancestry in Europe doesn't date to hunter-gatherers, right? The people who built Stonehenge are genetically closest to modern Sardinians, not modern British people. These are all the facts that I can just throw out there.
Wow.
Easily, trivially, I can reanalyze them. And that's because of ancient DNA, what's happened in the last 10 years.
So this information is coming from, how do they get this information? Is it from sampling bodies that they've dug up from those periods, or where does it come from?
Archaeologists have been digging up bodies and fossils and other things for decades, well, for centuries in parts of Northern Europe where archaeology and antiquarianism have been around for a while. And so, you take some of these samples and you see if there's any preserved DNA left in them. So these are called subfossils. They're not like dinosaurs. They're not totally mineralized. So obviously when you have a mammoth that's 10,000 years old, that was frozen, there's a lot of degradation, but there's still some DNA. DNA is a very robust macromolecule. This is why it's a substrate of inheritance. If DNA wasn't robust, it wouldn't be as useful as a substrate of inheritance, because you want information to be preserved with a high fidelity, and you don't want it to get messed up in the cell while it's in the cell, right? So over time, you get older, mutations build up, people get cancer, stuff happens. But if DNA was very, very weak, with structurally was not very sound, we wouldn't be around. It just wouldn't work so RNA, for example, is structurally very, very evanescent. It fades away really immediately.
Yes.
It's just RNA is a ribosomal, nuclear material that transmits from DNA to RNA to protein. So the DNA is the permanent stuff, the permanent sequence. The RNA is what's transcribed to translate into proteins. And so the DNA is, you can, with the oldest DNA that we've gotten so far is from a 900,000-year-old horse from Siberia from the Taimyr Peninsula.
Wow. That's crazy.
Yeah. That's probably the edge of possibility, but never say never. They figured out new technologies, new ways to get DNA out of the hyoid bone. I think it's in the inner ear, other things like that. Obviously the tooth, tooth enamel. It can be sealed away. So there's just a lot of technological possibilities there. Aside from DNA, they're using proteins as well now. Proteins can be preserved even longer than DNA. They don't give you as much information, but proteins, what I've heard talking to people, there's optimism that proteins can go back 5 million years, which is before the Pleistocene.
Wow. Now this is big, long time scales, but it still doesn't get us to Jurassic Park, right? We're talking 65 million years for that. Yeah.
So there's one laboratory in North Carolina State that claims that they're getting proteins out of dinosaurs, but nobody really believes them. So,
okay.
Honestly, it's not my field, but nobody can replicate it. So
that's suspicious indeed. Okay. So this is really exciting. So we can actually track the history of, this is paleo-history of human evolution or human migration, I guess, just by tracking the DNA. That's incredible.
Yeah. I mean, if the people are following you, they want to see. So I've written a lot about it on my blog, but if you go to my Substack, razib.substack.com, I have been writing about so for example, I wrote a 2-parter about 8,000 some words on Anglo-Saxons, and so basically, concretely, to give your listeners a sense of what I'm interested in. Well, I mean, I'm interested in a lot of things. I'm interested in selection. I'm interested in, conservative politics, whatever. I mostly write about paleo-history on my Substack because that's where I add value, where I can just tell you things you never heard. So, there's two stylized extreme ideas. Anglo-Saxons totally replaced indigenous British people, the Celtic-speaking people, or they were an elite, 10,000 mercenaries, Hengist and Horsa and clan, that slowly culturally dominated the local people, right? Well, it turns out that the true answer is in the middle, that about say, depending on where you are, probably 30 to 40% of the ancestry in England, Wales, and Cornwall, and Scotland probably too, is probably Anglo-Saxon, quote-unquote Anglo-Saxon, the Utes, the Angles, and the Saxons that come from northern Germany, southern Scandinavia, and then the rest of the ancestry probably dates to the Iron Age Celts, right? So the answer is in the middle. In my post, I outline the dynamics, but demographically, we got the answer. Once you have the demographics, then you can talk about how things happen culturally. And it's one of those issues where archaeology combined with DNA, combined with when we have it, linguistics and history, are much more powerful than the fields individually. They hold together synthetically as a unit, and they give a great deal of insight.
Now, that's really interesting to be able to say definitively what answer these questions. We're actually answering historical questions that have been posed by archaeology using the science of genetics. Is that?
Yeah, you can do deep hypothesis testing. We have the methods to test the hypotheses really robustly.
So what other new things have we learned about evolution in the field of genetics? Have we learned anything new?
Yeah, well, if you're talking about, like, besides humans, for example, one issue is in the 1970s, there's a huge argument about whether genomic evolution, well, I mean, they didn't use the word genome, but molecular evolution, sequences, whether it was mostly determined by random genetic drift or natural selection. So this was an argument between people like, Stephen Jay Gould and Richard Dawkins. Mm-hmm. And, the bigger term was like the neutralism, neutral theory controversy. Is evolution mostly a neutral process, or is it mostly a directed selective process? The TLDR on that is we don't really, the genomics people that I know don't really have a discussion about this anymore because we have so much data. You can just test the hypotheses on any given lineage. So there are species that have small populations that are drift dominated because small populations are more random. And then there are species that have large populations that are selection dominated because large populations don't evolve in a random way. And so this is like Leibniz's classic quip, let us compute. We're at the let us compute stage.
Okay.
So instead of having philosophical arguments, we actually test data because we got so much of it.
Wow. Yeah. That's really what I see in the field. It seems like a very lively field. And if you just search a few articles and there's so many interesting things coming out of it that it's like, wow, this is great. I love when you can answer questions with science. And from my impression, that tells you that you're on the right path because we're learning things that are just, so amazing right now in the field. I've looked at endogenous retroviruses in the genomes showing common ancestry between humans and chimpanzees. I've looked at ancestral protein reconstruction articles, which is amazing. And you can sample the gene sequences of extant species and from that mathematically predict what the gene sequence was in their last common ancestor, and then build that protein.
Yeah, I think that's Joe Thornton's work at University of Chicago now, and he was at Oregon, and I actually was a student of his at one point, undergrad.
Oh, okay.
But he's a good guy. Really fascinating work. I did use one of his computers in the computer room one time, and I crashed a simulation. He just came in and he's like, "Are you doing something?" And I was like, "Yeah, I'm just working on my homework." And he's like, "I'm using these." And I was like, "Okay, well, if you're going to parallelize, you know what I'm saying, bro?" It's like put a password on it. I'm here, Anyway.
Cool. So, preparing for this interview, I noticed that you made news when you sequenced your son's full genome in utero.
Yeah,
that was a first, right? Has this never been done before? You were the first person to do this?
So my older son, I have two. My older son is the first human being born alive who was whole genome sequenced before he was born. There were in non-viable pregnancies where sequencing had occurred. Yeah, that's the way I'll say it.
Right. So, that seems like a potentially dangerous thing to do. What drove you to do that? Why did you go ahead and do that?
Why would it be dangerous?
I don't know. From my limited understanding, anytime you're sampling in utero, you potentially pose a risk. What was behind that?
Yeah. So there's two ways to think about this. There was a potential risk with the way you're talking about the way I did it, but right now what they're actually doing and what will happen is probably sampling out of the mother's blood, non-invasive sequencing. It's strong enough to detect Down syndrome now, which is why most Down syndrome pregnancies are terminated, they're aborted in the United States now. They just do a blood draw from the mother, early second trimester, and they they just get it from the blood. And they will do that. So the Jay Shanduria's lab in Washington, University of Washington, is working on that. So that'll come out. So what we did is chorionic villi sampling. It wasn't amniotic, actually. It was chorionic villi sampling, which goes at like some sort of placental tissue.
Okay.
There is some evidence in the literature of elevated miscarriage rates, but I don't really believe that that's true, because a lot of these things have ascertainment bias and what type of populations are being sampled. So what subset of mothers do the chorionic villi sampling is not a random subset of the mothers. And so I don't think that the risk was actually any higher, to be candid.
Okay. And so what were you hoping? It was basically just a precautionary measure to see if there are any problems early on. Is that your plan?
I mean, honestly, mostly because it was cool. I thought someone had done it before, so I was like, oh, can I do it? I was in grad school at the time, and I was like working on whole genome sequences, and I was like, oh, it'd be cool to get, because I'm in grad school, we have facilities and abilities to just like do this.
Okay.
And also the fetus was in utero. It's not legally a human yet.
Sure.
I mean, you could terminate, you could abort the fetus.
Mm-hmm.
So if you can kill the fetus, why can't you sequence the fetus? What's the deal?
So you got some flack for that?
Oh yeah. A lot of people were freaking out, but I mean, whatever. It's like a lot of people like in academia, they talk about eugenics and stuff, but like, most academics do eugenics themselves. In terms of like, a lot of them have children, a lot of them, either themselves or they're whatever. They have children later on in life. Okay. So you don't think they're doing non-invasive prenatal sequencing? They're all doing it. And what do you think they're doing when they have a Down positive for Down syndrome? I want to see how many academics are raising kids with Down syndrome. Mm. That will tell you what they're doing. When I point this out, when I point this out on social media, they never respond. So they're exactly doing what I'm saying.
Mm-hmm, mm-hmm. Are you worried about the implications of this at all, or are you behind the idea of eugenics? What's your position on responding to various things, or maybe even genetically altering things that you don't like in the genome?
Yeah, so I mean, we're going to genetically alter people with not Down syndrome, but cystic fibrosis and ALS. So like CRISPR genetic engineering, that's going to happen because these people as adults, they're going to die early if you don't. So these are the first humans. I mean, there's already been some New York Times published trials on a girl cured of sickle cell. Okay. There's a lot of adult Mendelian diseases that people are carrying around. So I had an acquaintance, and for whatever reason, the genetic test did not pick up that this infant had cystic fibrosis. And this guy is like asking me, how will we make sure that our daughter has a good life? And I said, I'm going to be honest with you. I don't think she'll have cystic fibrosis by the time she's 30. Because she's going to get genetically engineered. She's never going to be a marathon runner. What they're going to do is they're going to do some sort of targeting of this tissue in her lungs and genetically repair some of these cells. Like she has 2 bad mutations. They're going to transfect somehow the cells. They're going to CRISPR cut out and put in good copies. And once you have like 10% of your lung tissue being back to normal, you're never going to be a marathon runner. You're never going to be a great endurance athlete, but you're probably going to live your whole life.
Yeah.
Right now, people with cystic fibrosis die usually between 40 and 50, I think.
So in your opinion, they're going to have the technology to be able to fix this in living people. This is, altering a few of the cells. In the next 10 years. Wow.
I think in the next 10 years, I predict the cystic fibrosis will be cured functionally.
Wow.
Like, because you'll target adults. You'll target like 40-year-old adults with cystic fibrosis who are at the end of their life. Mm-hmm. So that if there's a problem, and there are problems, and so that's why people are very cautious about it. But if you're on death's door, and then there's cancer, like with cancers and stuff, I'm assuming that will be also targeted with genetic engineering at some point. But cancer is harder than cystic fibrosis, because with cystic fibrosis, you got all your lung tissue has like bad mutational cells. I think it's the CFTR gene. Anyway, like you're dying because your lungs just cannot function correctly. So if you had like just some normal functional cells, that'll be good enough, because most of the time you're not like running a marathon, you're not sprinting. You're just trying to breathe, you know? So that's going to happen. ALS, which is a neurodegenerative, musculoskeletal disease. I think I know that's being, that is being genetic engineering through CRISPR-Cas9. They are doing trials in dogs. Because dogs have big muscles and sort of the good model organism, and some of them have ALS, I guess.
That's interesting. That's definitely amazing to learn that they're that close to being able to genetically alter living humans. And then, of course, the next step is looking at germline mutation, or fixing germline mutations in these.
Yeah, that would be the, like, if you want to like tell your listener or viewer what germline, because like important distinction, somatic versus germline.
Please go ahead and give us the geneticist.
Okay, so basically, somatic is just like your regular cell tissues that aren't being passed on to the next generation. Germline would be sperm or eggs, right? It would be like sex cells, basically, that are passed to the next generation. And so germline editing would be, let's give like a concrete example. You got an embryo, it's a test tube baby, and it's got like some cells now. It's reproduced to some level. And you transfect it, or you edit it to fix all of its mutations. Because what you can do is you can get a whole genome sequence of something from the embryo, get a whole genome sequence, and then take that whole genome sequence, find all of the editing errors, and then from that, you can fix the errors in theory. This is going to happen probably in like 20, 30, 40 years. I mean, it's going to be later depending on where you are and who you are, because the issue is what we call off-target effects, which is basically like, it edits something else, it causes another problem, like a cancer or something like that, right? You don't want that. You don't want that. So
this is starting to sound a little bit like a Black Mirror episode that I watch, and obviously you have a lot of science fiction about eugenics, about you have to be perfect, and the difference is then called out. It's a bit of a slippery slope. You need to. What's your opinion on affecting disease genes versus just affecting the actual everything else about the germline?
Yeah, so I think disease is going to be hit first. I don't think you're going to have huge arguments about disease. I do think genetic screening is going to be like the first thing that you do. So when it comes to the germline, probably you're not going to edit embryos for a long time.
Okay.
Like what you're going to do is select from a bunch of embryos.
I see.
Okay. So if you have two copies of, you're going to select through screening first. I think that's going to be happening first, probably for the next 10 years. And then some people want to edit embryos. What they're going to do is like, I don't have a perfect embryo, so I'm going to take the best embryo and then I'm going to edit it. That's what they'll think. And what I personally think about it, because I think you've asked a couple times, I'm pretty much a genetic libertarian at this point, but I'm open to legislation. But basically, we just need to have a conversation about it and not be hysterical. I don't think people are actually being super honest about what's going on right now. When a lot of academics talk about eugenics, like I said, they actually do it all the time. They're just using a buzzword, But what does eugenics mean? Is screening Down syndrome eugenics or not? That's a debate you can have. I heard like there's some diets that are like eugenics because they're anti-fat person or so. I don't know, just stupid things like that. Some academics like engage in that sort of talk, So let's be precise about what we mean by eugenics. Is it allowed? Is it not allowed? What's the legislation? What's the moral impact? We don't want everyone to turn into a clone. There are some genetic reasons for that, like everyone to look exactly the same and have the exact same genes. So there might be an issue so there are possibilities. So I'm a genetic libertarian, like I'm like individual choice first and foremost, but there are issues where there might be coordination or collective action problems where you don't want everybody to have the exact same genome. You don't want all humans to be exactly the same. Right? But if everybody wants this exact same perfect human, maybe everyone's going to edit that way. So you just have to like think about it and set up society in a way where this is fair, this is just, and this is best for everybody. But again, it requires rational discussion.
Well, that's what we're here for at The Rational View, is to open up these issues and discuss them and listen to people's opinions and figure out where we should be going. So this is not the direction I thought this interview would be going, but it's very interesting, and I think it's as you say, this is an emerging field that has important repercussions for health, and it also has a lot of moral issues that people are going to be worried about, and we should make sure that we're very clear, as you say, because you're right. There are people selecting embryos now on the basis of trisomy 23 or on the basis of Down syndrome, basically. And is that eugenics or is it not eugenics? That's a very good question. It's a difficult thing that any parent has to deal with. You know, do you look? Do you check beforehand? How would you feel? Are you prepared to have a child with Down syndrome and support that for their life? That's a very difficult thing that parents have to deal with.
Yeah, but I mean, as I said, we do actually know the empirical. I mean, it depends on the country, depends on the subculture, subpopulation, but we know on the whole, yes, people are willing to check, and on the whole, people do not want children with Down syndrome by the choices that they make in the United States. As you know, I mean, you guys can go to Google. There's hardly any babies born with Down syndrome in Denmark at all, because there are so few pro-life Danes. So I had I'm not going to name him at all, so I think I can say this. I had a friend, and his child had, it wasn't Down syndrome. It was something actually way worse. And I'm using past tense because it was something way worse. Okay, the child's not around anymore. But in any case, his wife is pro-life. He's pro-life. There was no option for them. There was no choice that they were going to make that was different than bringing the child to term, and what happened. So people are going to make that choice. As I said, I think people should be allowed to make that choice, and people should be allowed to make the other choice. That's my opinion. But again, just my opinion, and different societies are going to make different choices based on their values.
Sure.
Like if you're pro-life, you're never going to want this to be a choice at all. But the issue is not the eugenic aspect for them. The issue is they think it's a life, right? So. Okay.
Yeah. No. And indeed, that there's definitely religion that intertwines with this, and people's opinion on when life begins is also a politically fraught issue that people have to deal with, especially in the U.S. The big push for against the or the pro-life push, I guess, as they call it, against the pro-choice movement. Very highly polarized debate in the U.S. Maybe not in other areas as much, but it seems to be at the root of a lot of people's fears right now with all the political situation there.
Yeah. I mean, it's although pro-life and pro-choice, by the way, is like one thing in the United States that has stayed polarized. Like stuff like gay rights and all that have changed, right? But on abortion, nothing's changed.
So maybe getting back to evolution and creationism, have you encountered creationism in your writing? Have you ever tackled that issue, or do you stay away from that one?
I used to back in the day. A lot of us in the bio-sci online communication sphere come out of Usenet groups like Talk Origins. Yeah,
I was there.
So okay, so those are debates. I mean, yeah, maybe we remember. I mean, were you in the atheism Usenet groups?
Not really. Not at the time.
But anyway, so yeah, atheism, Talk Origins, all these groups. A lot of us were in there. Some of us grew up in I did grow up in very conservative areas. There's a lot of creationists. These are day-to-day debates that we would have, and kind of like added to the armamentarium of our ability to discuss these things. Obviously there are books you can read. Like I think Robert Pennock's book was a really good one. Anyway, there's a bunch of stuff you can read, but also like online and the news groups. And so, but creationism is not a major issue in the United States, in my opinion, anymore, just because we're just so much less religious. When I was a kid, I mean, when you were a kid, right? Like when we were both kids, it was like 10% of people said that they had no religion. And today it's like 30%. I'm a Republican. I'm conservative. I can tell you, like in 2008, I had a blog about non-religious conservatives, and that was like big controversy on the right. And in 2011, the New York Times profiled me as like a conservative atheist along with Heather McDonald and a few other people. And it was just a big deal back then. Today, it's not a big deal. There's a lot of people on the right who are openly now not religious, whereas in the past they were just closeted. And so even on the right, things have changed. On the left, I honestly think if you're an evangelical Christian, it would probably be a little uncomfortable unless you were an ethnic minority.
You don't feel uncomfortable being an an atheistic Republican?
No, because like I'm okay with making people uncomfortable. So if they want to make me uncomfortable, that's fine. I'll argue with you.
Okay.
Like I've never had a problem. Like I grew up in Eastern Oregon as an atheist, so I had never had a problem arguing with people about that. And you can imagine most people in Eastern Oregon do not look like me. Like, you know, my local hometown paper had an article called "The Blacks of Union County," and it profiled all 15 of them. Seven of them were members of one family. So,
Oh my.
Yeah. So I'm used to being in the minority. I don't back off.
Yeah. So I also was on Talked Out Origins back in the day, and that it seemed like a much more topical argument back then than it is now. And I agree. It seems like the social argument on evolution and creation has moved on. It's not as big of an issue as it once was. Although, there's still a core group of fundamentalists led by Ken Ham and his ARC Experience group in Kentucky, I think, that are pushing that.
They're refugees from the 20th century.
Yeah.
It feels a very 2006 vibe. In terms of just like, oh, it's like Richard Dawkins, the root of all evil, that whole scene, which was interesting. And it was at the, there was half a generation ago, it was still a live debate whether the evangelicals and the conservative Christians in the country could be culturally ascendant. They didn't have control of Hollywood, obviously. They don't have control of a lot of the intelligentsia, but, George W. Bush was a convert to evangelical Protestantism and, choose the right. Back in the late 1990s, NSYNC used to, I think, pass like virgin bracelets, or I don't know what they were called, but bracelets to show their, you know what I'm saying? Like cultural conservatism, Christianity was, not necessarily cool, but it was a possibility. Now today, actors in Hollywood who are clearly privately conservative Christians, they try to cancel them on Instagram and stuff, like call them out, and so it's like the culture has totally changed. And to be entirely candid, I don't fear conservative Protestants anymore. And as someone on the right that's been targeted for cancellation, I do tell them, I'm like, you might think I'm going to hell, but we got the same enemies at this point. So you guys need to like chill out. Like I'm pretty tolerant, but you're alienating people. If you think that it's still the year 1999 and you guys actually have a shot at cultural ascendancy, like your goal should be to survive, not to dominate, because you're not going to dominate. And a lot of them are pretty open about it now. I mean, why did they vote for Trump? He's obviously not religious. He's obviously probably not even really a Christian. Like he's a cultural Christian, but he probably doesn't. I mean, he didn't know what like the Eucharist was. I mean, he doesn't know any of this stuff. Okay, but they voted for him mostly because they thought he would defend them, and so that's all they. I mean, like a lot of them at this point have conceded they've lost the cultural war, and now what they want to do is retrench and survive. And so the configuration of everything is changing. When we were kids, being gay was dangerous in a lot of this country. And it's still not the best in a lot of this country, but it's a world of difference now. It's a world of difference, I have very young male, gay male friends who, I tell them, I'm like, because like sometimes they'll be like, you seem cool, but like some of the gay guys that I know your age, they're a little weird and like a little, and I'm just like, okay, but you don't know how they grow. You didn't experience what they experienced, right? Where you had to like live a lie of who you were. Like as a teen, like you had to date and have girlfriends as a gay man in the 1980s and 1990s, like maybe you could like come out as an adult, but you had to go through a fake phase, or you might be physically in danger, and so, there are kids today, I meet occasionally like, undergraduates and stuff in their early 20s, and they're just like, yeah, like I don't understand why they're so jumpy and stressed. And I'm like, well, you don't have their life experience. Like you entered your sexual years as a gay person, as, someone who liked the same sex without any shame or fear. And so that's just changed totally in a generation from what I've seen in large parts of the country, not everywhere and not in every subculture, but my point is like, things have changed a lot in my lifetime, some for the good and I think some for the bad, so that's just how it is.
Yeah, the social discussion has definitely changed over half a generation. And yeah, it's definitely the popular opinion has shifted quite a bit. Obviously, there's still, as you say, areas where it hasn't shifted. And I think it's the same thing on creationism, that there are areas that are still dominated by the evangelical position in small pockets, I guess. And there are still a lot of people that are pushing an agenda into schools in these areas where they try to stop the teaching of evolution or teach the controversy, which ends up being in an area where it's dominated by these evangelicals. It ends up damaging the educational prospects of the children that are being indoctrinated against evolution in that way, I think. So I think that's where this becomes an important issue, is in allowing kids to learn the science unopposed by basically religious dogma. Keep the religion in the Sunday schools and keep the science in the science class. And that's why I think it's important to get out the ideas and the discoveries of modern genetic science, because this is, I think this may be one of the reasons why the debate moved on, is that the evidence from genetics after the Human Genome Project especially has been so deafeningly in favor of evolution that you have to actively hide your head in the sand to believe otherwise, I think.
Yeah, like phylogenetics wouldn't exist without evolution. Mm-hmm. I mean, it's just like there's whole fields of science that are driven by genomics and big data that just seem to confirm evolutionary. I mean, like the stuff that I do, I couldn't do it if evolution wasn't a thing. I don't know.
Okay, can you expand on that a little bit? You said phylogenetic.
Well, I mean, so you were talking about phylogenetic reconstruction, right?
Okay.
Like, well, how does phylogenetic reconstruction of ancient proteins work? Well, it works by assuming the tree of life, by assuming evolutionary processes, these branching processes. So none of this would work if evolution wasn't a thing. So let's just say if God created, everything unique, to each unto its own kind, all that stuff. Like, why would you have a tree of life that looks like this? Like, why does morphological similarity on these functions have correlations with evolutionary? It's just like the whole thing is not structured. And as you know, it's not just like characteristics, it's genes. Like, they're structured in a way where they look like they're contingent processes that A leads to B, but it's not like they're optimized perfectly. Mm-hmm. That's an evolutionary process. That's not like a special creation process. Like, if you're going to do a special creation, you'd create a small genome basically there's a lot of features of the genome that look like they're the process of like detritus from evolutionary history. They don't look like they're like adaptations. Well, why would you have that in the genome then?
Yeah.
If you're special, why would you add junk? If you're God, why would you add junk in the genome? Tell me that. You know what I'm saying? It's just like, it doesn't make any sense.
Yeah.
Like, our genome's mostly junk. Human genome's mostly junk.
That's an important point that a lot of people that aren't geneticists don't understand. Like, the genome doesn't lay out coding blocks. It's not like a recipe book where it's all makes sense. It's more like, start here and then there's a flipped pit here, but then go over this way and then reconstruct it this way. And there's a big area of junk in between. Like, I think, what is it? Something like 95% of it is junk.
99. It's 99. It's about 99. So, like, basically what you say is like the exome, the protein coding, the protein coding genome is about 1% of the 3 billion base pairs, right? Something like that. Okay. And then the rest of it is intergenic. Now, some of it is like transcribed in weird ways, but really it doesn't translate into protein. And there's arguments whether some of it might be functional in some way in tertiary DNA structure. Those are complicated topics. Really, the ultimate fundamental truth of it is 99% of the action happens in 99% or in 1% of the genome. Okay. For humans. Now, for bacteria, it's almost all genic. And why is that? The argument is that bacteria are subject to really strong natural selection. So it selects even against junk DNA because the very act of replication, DNA replication in bacteria, is actually under selection because they reproduce so fast. Their generation times are so fast that the very act of replication is a rate limiter. With humans, that's not true. Like DNA replication is not a rate limiter. We live so long. And so there's no selection on the DNA replication process in terms of optimize. So this is a theory in terms of optimizing for a compact, wholly functional genome. Instead, we have all this crap that came on, these retroposons, these, transposable elements and crap like that.
Sure. The energy that you need to reconstruct all this junk doesn't hurt you. It's a negligible fraction of your life energy.
Exactly.
That is very cool. So I didn't realize the difference between bacteria genomes and higher organism genomes.
We don't use the word higher organisms now. You want to use metazoans or complex eukaryotes? I'm just saying, don't use a great chain of being, dude. You know what I'm saying? we ain't with Aristotle and Aquinas anymore, right? There's no higher or lower life forms. They're just life forms. We all descend from our common ancestors equally, complex or not complex. I mean, what are mitochondria? Mitochondria are basically bacteria that were absorbed by some, protist-like organism and turned into the cells. And here we are, human beings, made in the flesh of this, tree of evolution. I mean, if you're religious, like I said, I don't really care about religion too much anymore, partly because it's 2022 and that's not what the culture war is. But, people care, and if you're religious and you want to believe in evolution, I'm fine with that too. Actually, I don't really care too much about whether you're religious or not if you don't bug me. Just don't tell me about how I need to be religious to be moral, or how evolution's wrong because God said so. I'm I don't want to hear that. Now, if you say that well, I believe in God and I believe in evolution, I don't want to hear about your God stuff. I don't care, but talk to me about evolution. That's what I want to hear about. That's what I'm passionate about.
It definitely comes through in your writing. I think it's a fascinating subject, and I appreciate bringing this to the people and letting people know what is going on in this field, because it's a challenging and difficult field. You need a certain background to be able to understand what's going on. So I'm trying to kind of illuminate the science and just show how solidly that this backs up the theory of evolution. And now the theory of evolution, there's not one quote unquote theory of evolution, right? There are a lot of different theories of evolution, as you hinted earlier about neutral versus natural selection versus neutral flow versus punctuated equilibrium. There's lots of theories about how genomes progress over time to create and what selective pressures and what random things, what the balance between these things are. So there's this controversy in the field which is normal in a healthy scientific field, that is sometimes amplified by people who don't understand it or who are pushing an agenda to say that people don't agree on the theory of evolution. And I think that's the wrong thing to take away from a healthy scientific investigation. We know that common ancestry is true. We know that universal common descent is a thing. This is so factual that you almost cannot disprove it at this point. It's so heavily supported by the evidence, right? So we're not worried about that evolution has happened in some way. We're arguing about the details at this point, right?
Well, yeah. So think about evolution. Think about evolutionary theory, Darwin's theory of common descent with adaptation being driven by natural selection. This idea of the tree of life. Think of that. I think listeners and viewers can think of that as, the scaffold of a house, the wooden or stone scaffold of a house, the superstructure. We're at the stage where we're building the rooms and installing the tubs and figuring out the exact layout. So if you're just coming in, you're this scaffold, it's not right. I'm just okay, you know what? I'm working on some details here. I don't want to have this stupid argument that actually we should do a totally different scaffold because this doesn't work. And I'm it works. We got a roof. Okay. We got a roof, the interior heating's, I'm just remodeling now. Okay. I'm figuring out the details. I'm not going to have this argument about where the house should be built and how it should be built because it's done. Okay. That's how I'm feeling. I don't want to have discussions about creationism because life is short. I'm going to die someday, hopefully later than sooner. And there's so much I want to know. There's so many papers I want to read. There's so many analyses I want to do. You know, it's like, we have bitten of the apple, you shall be as gods, you know, like we shall know, you know, drift from selection, you know? And so like, let's figure this out. You know, I was about to swear. I'm just like, let's figure this out. Like, this is how I feel when I'm like, hear about creationism. And I'm just like, okay, can someone else take care of this? Because like, I got stuff I want to do and stuff I want to learn. That's the stage I'm at. I'm not like a, you know, 18-year-old virgin that's like, you know, taking my first biology classes, typing away, in Pine, sending emails to creationists, you know? Like, yeah, that was me. I put in my dues at the terminal, arguing about evolution and creation. Somebody else take it up right now because I got more important things to do. And this is an exciting time. I mean, arguably my grown ass adulthood has been the most exciting time in genetics since the first decade of the 20th century when the field first reemerged, when Mendel's ideas were rediscovered. You know, in terms of like, we went from one human genome in the year 2000 that cost $3 billion to my son being sequenced in utero in 2014 to my whole family being sequenced for $200 each in 2020.
Wow.
$3 billion to $200 in 20 years. Okay. There's probably 10 million people sequenced right now, whole genome sequenced in the world. Okay. There's probably going to be 100 million in 5 years and then 1 billion in 15, 20 years.
That's amazing. So where is this going? What is this going to tell us? Are we going to, what's the next discovery? Give me a prediction of what we're going to learn in the coming years.
Well, I think one of the things that is going to be heavily explored. So Darwin's original theory was predicated on adaptation through natural selection. We're going to understand a lot more about adaptation. A lot of the stuff that I talk about on my newsletter, on my blogs right now is about the tree of life, filling out the tree of life. Once you have the tree of life, you have a phylogeny. You can figure out how adaptation works within that phylogeny. And there's a lot of research groups that are doing the tree of life right now. That will move to understanding the adaptive process, natural selection within the genome in the next couple of decades. Now, that is a very, very involved process because it's computationally much more intensive. There needs to be experimental science, bench science done to validate these functional pathways. What do they really do? And so I think that's what I'm excited about. That's what I'm going to look at. That's what I'm going to see. That's one of the major things. The other thing I do have to say, if you're a medical geneticist, and I am not, I do more population level work, is pretty straightforward that CRISPR-Cas9 genetic engineering is going to transform the possibilities. And we also talked about medical genetics, obviously, but you know, what about agriculture? What about domestic animals? You know what I'm saying? There was a South Park episode where like Dr. Island of Dr. Moreau guy is like creating pigs with 3 butts and stuff like that. We're going to be able to create pigs with 3 butts. Like we're going to be able to create man-bear pig, you know? So, I'm not saying that we should. I'm not saying that we should, but I'm just saying that like, there's going to be some like rich dude in the Gulf who's like, I want to create the horse camel. I'm not even joking. Like 10 years ago, they actually entered, commas, male, I think it was like the offspring of male camels and female llamas in camel races in the Gulf. And they kept winning because they're commas. Right? They got the llama. And then they were like, like no more commas, please. Like, this is not fair. Like, we're not going to do these transgenic, animals or trans species animals, so anyway, people are always trying to figure out an angle. And so science is going to be used for that sort of stuff. And I'm interested to see what happens. I'm excited about the medical genetic discoveries and breakthroughs that are going to happen. But I'm also curious about the weird things that we can't think about or realize, maybe somebody wants to be like, I want to be different. I want red skin, like literally red skin. So there's some like genetic topical treatment that, does something with the cells in your face. But how do you go from red to unred? What if you want to change? Like if you get a tattoo, you can get the tattoo removed. Like it's hard sometimes, but you can do it. But what about like cells? Like, do you want to keep transforming your cells? Some people will. Someone like Joshua Zahner, people like that, they will transform themselves just like people. There are always people who have like full body tattoos over their whole body. And then, whereas most people have one tattoo, most people who have tattoos have one tattoo. Most people that do genetic engineering will do it for, 1 or 2 reasons, usually disease. But there's going to be some people that actually want to re-engineer themselves in some deep ways, and that's their choice.
Mm-hmm. Well, this is an interesting conversation that we've broached here, and you're right. We need to have this discussion because the capabilities are going to be there. And if society doesn't start talking about them, there's going to be people doing things like you say. There's going to be camels with
three butts. Camels with three butts.
Pigs with 3 butts. And someone's going to want to start fiddling with their own DNA. So this is a timely conversation, and thank you for bringing it to our attention, and thank you also for helping us understand evolution and genetics and where the field is going. I really appreciate having you on the show, Razib.
Yeah, my pleasure, Al.
I'm gonna send you a Rational View T-shirt if you'd like, so you can represent to your audience as well. And
all right,
just going to leave it with the last question. What kind of science fiction do you like?
What kind of, so I mostly like Stephen Baxter type stuff. I haven't been reading science fiction very much over the last 10 years, partly because I got 3 kids, I got jobs, I got stuff on social media to do, defend myself from cancellation for the 12th time, But I like Stephen Baxter. I really like hard science fiction. Robert L. Forward stuff was a little bit much for me because he just focused a little bit on the science. But sometimes I like the Hal Clement short stories, and then every now and then I like a Werner Vinge space opera. Deep in the Sky and stuff like that.
Yeah,
I actually
nice.
met Werner Vinge a couple of times, Singularity Summit in the late 2000s. I had beers with him, although he didn't know who I was and I barely talked to him, but I was like, I'm talking to Werner Vinge, and I'm sure everyone else was thinking that when they were having a beer with him too. So,
awesome.
I like that stuff. Yeah.
All right. Well, thanks so much.
My pleasure, Al.
If you'd like to follow up with more in-depth discussions, please come find us on Facebook at The Rational View and join our discussion group. If you like what you're hearing, please consider visiting my Patreon page at patron.podbean.com/TheRationalView. Thanks for listening.